Hi everyone, welcome to the third of my revision videos which focus on the challenge of natural hazards. So this unit is broken up into three sections: tectonic hazards, weather hazards and climate change. In this video we'll focus on climate change. With regards to climate change, what do you need to know? Well, everything you need to know is on the screen there. This video will of course cover all of it, but please feel free to pause the video at any point to have a little read through that. So the examiner expects you to explain evidence for climate change from the beginning of the Quaternary period to the present day. But what is the Quaternary period? Well, Earth's history is broken up into three eras. Within those eras there's different time periods, the most recent of which is the Quaternary period, stretches back from 2.6 million years ago. So within the Quaternary period there's been numerous warm periods, cool periods, and we've had the evolution of modern humans as well as many mammals that have become extinct, probably because of the change in climate. So as I say, there's been many warm and cool periods within the Quaternary period. This graph here shows how the temperature has changed over the last 800,000 years. The cooler periods generally we call ice ages, and the warmer periods we call interglacials. Yeah. Now, how do we know that the climate has changed or is changing? Well, there are some recent pieces of evidence that help us understand how the climate is changing. They're on the screen there now. They're seasonal changes, rising sea levels, an increase in ocean temperatures, and shrinking glaciers and melting ice. Yeah, hopefully they're pretty self-explanatory, but please pause the video now and have a little read through, take notes if you need to. There's also historical evidence of climate change, evidence that stretches back hundreds or thousands of years from the days before modern temperature recording devices. So how do we know what the temperature was like back then? Well, four main ways are on the screen there now: ice cores, fossils, tree rings, and ocean sediments. Okay, so ice cores involves drilling deep down into ice, normally areas such as Antarctica or Greenland. Scientists have been carrying out experiments there for 20, 30, 35 years now, and they've been extracting ice from up to 3 kilometers below the surface. Okay, now these ice cores, they show a series of rings which equate to 1 year's worth of snowfall. By analysing the concentration of gases in the rings, so that's gases such as water vapour, carbon dioxide, oxygen, methane, scientists they've been able to build up a picture from past climates. As well as this, analysis from pollen trapped in the cores, plants and trees that previously grew in those areas. It's also helped to improve the accuracy and being able to estimate the temperature of that area in the distant history. We can look at fossils, okay, large creatures or megafauna. By studying their fossils, we can look at their diet and what the habitat was like, and we can understand what the climate of the area was like from that. We're going to look at tree rings. So some trees, incredibly old, particularly trees such as the bristlecone pine in California, that can grow up to 3,000 or plus years old, sometimes 6,000 years old actually. And by studying the tree rings, that gives us an idea of what the climate was like all those years ago. Thicker tree rings indicate a warmer, wetter climate. Narrower tree rings can they indicate a colder, drier climate. Yeah. We can also study ocean sediments to give us an understanding of how climate has changed. So yeah, we can analyse fossil plankton from areas such as the Baltic Sea or the Black Sea. Generally higher temperatures leads to increased rainfall and therefore lower salt levels within the sea, and this has a direct impact on the amount of plankton found on the seabed. As I say, if you need to pause the video at any point to take some notes, please do. So as we can see, there's been many fluctuations in the Earth's temperature throughout the Quaternary period. As we can see in this graph again, we've got the cooler periods known as the glacials and the warmer periods known as the interglacials. But why as the Earth's temperature fluctuated over this time? Now, modern humans have only been on Earth for the last 200,000 or 300,000 years ago. That suggests that these factors are natural. And there's three natural causes of climate change that we need to understand. First of which is what we call the orbital theory. Over periods of thousands of years, there's been small changes in the way the Earth moves around the Sun. These are called the Milankovitch cycles. We'll get warmer temperatures as we get closer to the Sun, and we get cooler periods as we head further away from the Sun. If you need to pause the video, have a little read through this information, please do so now. The second natural cause of climate change is the sunspot theory. So increased sunspot activity leads to more solar radiation and increased temperatures. Again, there's a lot of information on the screen there now. Please have a little read through by pausing the video. And the third natural cause of climate change is what we call the eruption theory. So volcanic eruptions send vast amounts of dust into the air. Now this dust can reflect heat back out into space. Dust from huge eruptions like those of Krakatoa in 1883 and Mount Pinatubo in 1991 have been linked to the decreases of the Earth's temperature in those time periods. Again, please pause the video now, have a little read through this information if you need. So there are natural causes to climate change, but there are also human causes of climate change, and there's three main human causes which we'll talk about in a second. Firstly, this graph here is just going to illustrate the impact humans have had on the climate. Okay, so it's similar to the graph I showed you earlier on. It shows the last 400,000 years, and it shows again how the temperature has fluctuated over that time period. But if I reveal to you the current trend, okay, it's the carbon dioxide levels have never been as high as they are today. Okay, and obviously humans are responsible for this. Before we talk about what we are actually doing to cause climate change, we need to understand what the greenhouse effect actually is. Okay, the greenhouse effect is completely natural. Okay, without the greenhouse effect, there'd be no life on Earth. It would be far too cold. It is just a blanket of gases around the Earth, greenhouse gases, that trap some heat on the surface. So as the solar radiation comes in from the Sun, some of it is reflected off the Earth's surface and back into space, but some is trapped below those greenhouse gases. Okay, that gives us just enough heat to survive, to sustain life. We're not too hot, we're not too cold, we have the perfect temperature. The enhanced greenhouse effect, however, is as a result of human activity. Okay, more greenhouse gases that are emitted because of human activity has caused this blanket of gases to get thicker and thicker around the Earth's surface. Therefore, more heat is being trapped on the surface of Earth than ever before. And the difference between the two are shown by these two diagrams here. Okay, natural greenhouse effect is on the left. The enhanced greenhouse effect, showing that thicker blanket of gases, is on the right. What greenhouse gases are we talking about? Well, mainly we're talking about methane, water vapour, nitrous oxide, and of course carbon dioxide. And there is completely a link between carbon dioxide in the atmosphere, which is shown on the left there in graph A, and the average temperature of Earth, which is shown in graph B on the right there. Okay, so what are humans doing to increase the amounts of greenhouse gases, therefore causing climate change? Firstly is the burning of fossil fuels. So the use of fossil fuels releases large amounts of carbon dioxide and other gases into the atmosphere. Coal, oil and natural gas were all formed over many millions of years ago, hence the name fossil fuels. But since the mid-1700s, they've been burnt at an increasing rate by industry and power stations, cars, planes, other types of motor vehicles. And it's thought that since about 1750, there's about 30% more CO2 in the atmosphere than there was previously. Okay, so the burning of these fossil fuels plays a huge role in the warming of our planet. If you need to pause the video now and have a little read through this information, please do. Deforestation as well. This is the mass cutting down of trees. Trees, as we know, they store carbon from the atmosphere. As trees are cut down, it means that there's less trees available to absorb carbon dioxide, but also when those trees are chopped down, the carbon that they have stored is then re-released into the atmosphere. Okay. Again, pause the video if you need to, have a little read through this. And then the third thing is changes in agriculture. Okay, so over the past few decades, there's been a worldwide increase in agriculture to feed the world's growing population. Crops that are grown need chemical fertilizers and pesticides which add greenhouse gases, including methane and nitrous oxides to the atmosphere. Methane is also produced by cattle and by decomposing vegetation in paddy fields. Again, pause the video now if you need to have a little read through this information. So why does any of this matter? Should we be concerned? Well, I'm going to talk to you next about some of the effects of climate change. Now, there's a huge range of effects on both people and the environment. I'm going to talk through some of them with you now. We're going to experience more droughts. Okay, so long periods of time without any rain. Obviously, this has impacts on water and food supplies for many people around the world. We're going to see more floods. We're going to see the sea level rise, which is going to threaten coastal communities. It's going to put people's homes, businesses, livelihoods at risk, forcing more people to move, migrate elsewhere to survive. We're obviously going to see even greater melting of ice caps and glaciers, which again is going to increase the water levels around the world, sea level around the world, threatening coastal communities yet further. We're going to see more extreme weather events, more hurricanes, tornadoes, things like that. Heat is the driving factor behind these storms. More heat means more storms. We're seeing more storms in parts of the world that didn't have them before, and we're seeing more intense storms as well. We're seeing more forest fires every year, some of them the biggest on record, causing huge impact to ecosystems and people as well. We're going to see more famine. I mentioned before, food supplies and water supplies are going to be threatened across the world. We're going to see, because of that, downturn in the economy of some countries, and also we're going to see an increase in diseases and pests because of these warm conditions. Now, there's a multitude of effects on people and the environment. If you need to pause the video now, have a little read through them, please do so. So what can we do about climate change? How do we tackle this problem to reduce some of these effects that we have seen? Well, there's two main approaches. First one is mitigating climate change, and the second is adapting to climate change. So firstly, mitigating climate change. Mitigation, what does that mean? Well, basically it means reducing the severity of something, making something less serious. Okay, so how can we change our behavior so that climate change isn't as much of a problem as it is today? Well, there's four main strategies to mitigate climate change. We can use alternative energy, we can capture carbon, we can plant trees, and we can sign international agreements. Okay, there we are, mitigation. So all the actions taken to reduce the causes of climate change, and there's the four main strategies that we need to know about with regards to mitigating climate change, making it less serious. Firstly, international agreements. So international agreements, they encourage countries to take responsibility for reducing CO2 emissions. Targets are more likely to be met if they are legal, if they are legally binding. So the most recent is the Paris Agreement, which was in 2015. Financial support might be provided for lower income countries. However, some countries are considered more responsible. It's hard to agree targets that go far enough and they may not be achieved. Okay. The first big agreement with regard to climate change was the Kyoto Protocol, and the most recent was the Paris Agreement in 2015. A little bit of information on the screen there if you have a little look, read through, if you'd like to pause the video. The second strategy to mitigate climate change is by using alternative energy. Okay, so we're not focusing on fossil fuels, we're looking for alternatives. So these could be examples such as wind, solar, geothermal, wave and tidal, as well as biomass. And these, of course, reduce greenhouse gases compared to burning fossil fuels. They'll last longer. There are downsides, however. They can be expensive and sometimes they're not as reliable. For example, if we're relying on wind farms, we need wind for that. Okay, if there's no wind, and we're not going to produce as much energy as we would on windy periods. Okay, again, bit of information there. Pause the screen if you need to. There's an example of the world's largest floating solar plant, which is in China. The world's largest offshore wind farm, which is in the UK. The world's largest hydroelectric dam, which again is in China, it's Three Gorges Dam. And there's the world's largest solar plant, which is in Spain. Some countries actually are almost 100% renewable. Iceland generates 72% of its electricity from hydroelectricity, and geothermal is 28%. Some islands, for example Orkney in Scotland, generate over 100% of its power from wind. And Paraguay, again, is a country that produces almost all of its energy from renewable sources. So some countries are doing much better than others in this sense. Okay, the third method of mitigating climate change is something called carbon capture. So this takes carbon dioxide from the emission sources and it safely stores it underground. An impermeable cap rock prevents it from escaping. It can capture up to 90% of CO2 and provide 10 to 50% of the world's total carbon mitigation until 2100. Downsides to this, however, are of course it's expensive and it's unclear if CO2 would remain captured long term. It doesn't promote renewable energy. Okay. Again, pause the video if you need to. And lastly, planting more trees. This removes CO2 from the atmosphere through photosynthesis. It could increase forest carbon storage by 28%. Oxygen is produced during photosynthesis, and trees provide habitats for animals, of course. Again, downsides, it might mean that land might be limited and biodiversity is reduced if only one tree species is planted. Once again, pause the video if you need to have a little read through that information there. They're the four main methods of mitigating climate change. So the second way to tackle climate change is by adapting to it. So with mitigation, we're trying to reduce climate change. Adaptation to climate change just means learning to live with it. So we're not trying to reduce climate change, we are just learning to live with the effects. Okay, and again, there's three ways that we can adapt to climate change: through agriculture, through managing our water supplies, and by reducing risk from sea level rise. Okay, so with regards to agriculture, changes in agricultural systems are required to deal with change in rainfall and temperature patterns. Weather's becoming more extreme, as we've looked at, and the changing distribution of pests and diseases. Production might need to move location to suit climates. Irrigation might be necessary, and the changes to crops and varieties might be required. Okay, these adaptations are most difficult for poorer farmers and LICs who are most likely to be affected. Okay, so it's all about growing crops to suit the climate in the area. We can manage our water supplies. Okay, so managing our water supplies ensures populations can face the challenge of change in rainfall patterns. So, for example, in London, this can involve reducing demand, such as installing water-efficient devices and increasing supply, such as opening a desalination plant so we can use seawater. In addition to water supplies being used under strain, security might be threatened as areas of deficit, especially where there's less political stability. And lastly, reducing the risk from rising sea levels. So how can we do this? Well, we could construct coastal defences, barriers such as the Thames Barrier, or restoring mangrove forests. We can raise homes, properties up on stilts, and we can relocate people who are at risk. There are, of course, economic and social downsides to these strategies. Maldives is one example of a part of the world they are learning to live with climate change. They are considering building sea defences, and they are considering also moving huge numbers of people from one of their islands to another, or even to another country. So, what have we covered so far with regards to climate change? We've looked at evidence for climate change. We've looked at causes, both natural and human, of climate change. We've talked about the effects, and then we've talked about how we can mitigate and adapt to climate change. Thanks for listening.